a lot of SAT prep because in Arizona, we did the ACT. And so I just was not as familiar with the SAT type of questions. So I've been doing a lot of SAT questions. And there's definitely some, once you do enough, you're like, oh, okay, I'm seeing some similar things kind of popping up over and over. Well, this is one of the things that was popping up on the SAT, central angles. And so central angles are what we're talking about today. And it turns out they're pretty easy. Central angles, we're going to find the measures of central angles and their intercepted arcs. So I'm going to talk about what an intercepted arc is. So a central angle is an angle with its vertex at the center of the circle, and its two sides are radii. So in this picture, here's the center of circle B, and so I have this angle that's created from here, a radius, because it goes from the center to the edge of the circle, and then another radius from the center to the edge of a circle. And so right here, angle ABC is a central angle within circle B. And I mean, I guess the name is pretty good, right? Center of the circle, central angle. Yeah, pretty good. So central angle goes through the center. Okay, really important. It's the vertex is at the center. The sum of all central angles in a circle. How many degrees to get all the way around a circle? Yeah, 360 degrees. So that's important to realize that all the way around the circle, a central angle would be 360 degrees. So you can kind of figure out, like, I need you guys on calculators today. So if this central angle, the pink central angle, is 84 degrees, what is this angle on the outside, other side? What's that? How'd you get that? Yeah, so you said 276? Okay. So 360 minus the 84, and we get that like 276. That's pretty good there. And so all the way around, we've got all these degrees that we can work with. That's pretty good. The measure of the arc formed by the endpoints of the central angle. Let's see. Let's talk about that. So what we have here is some notation you guys don't know yet. The arc we have the endpoint of our angle at A and another endpoint at C. This right here is called arc AC, and we use 2 points to denote a little arc and a little arc symbol on top, okay? This is what is called the intercepted arc. It's, imagine if that central angle were to close up, it'd eat the arc, okay? So imagine if you were to close that angle, that's the intercepted arc, the arc that it would eat, essentially, okay? So that is our intercepted arc. This is called a minor arc, as opposed to a major arc. What do you suppose the difference between a minor and a major is?
Smaller and major.
Yeah, major arc is bigger than 180 degrees. So this is minor arc, M-I-N-O-R. And over here in this purple, this would be a major arc all the way around, so major arc. And because it's a major arc, we do slightly different notation. It's so big we need 3 points to make sure we're getting the correct arc. So this is major arc ADC, all right? ADC, and I got a big arc on there. So this is major arc ADC. Again, we have our endpoints, and then one in the middle helping us figure out which side we're on, okay? So really important, we have major and minor arcs. Now it turns out that the measure of the arc formed by that central angle is equal to the degree of the central angle. Now that's the really important part. So it turns out that because this central angle is 84 degrees, we can also say that the measure of arc AC is equal. It's also 84 degrees. And because the large angle on the other side was 276 degrees, the measure of arc ADC, so this big, giant, major arc, is how many degrees? Also 276 degrees, okay? So if you know your central angle, you also know the measure of your intercepted arc, all right? So central angle is the same as the arc, and that's really important. So we want to find each angle and each arc measure. So once again, I kind of prefer just filling out the picture as best I can, all right? So let's look. I have a couple things here. First, I have this angle that's 122 degrees. This is angle SQT. What's this angle over here? True. What's its measure? How'd you get 58? From 180 degrees. We know it was 180 because it is a straight line. Yeah, 180 degrees is a straight line. This line, QT is a radius. What's RT? Diameter. Yes, this is a diameter. Very important there. Wow, my thing is very sluggish. Okay. Okay, so what is the measure of angle of arc ST out here? Also 122 degrees. Very good. And what is the measure of arc RS? Also 58 degrees. It matches the central angle. Very good. And what is the measure of major arc SRT? Let's see. SRT, that is this arc all the way out here. All right, SRT. Ooh, how do we figure that out?
58.
Yeah, very good. This side over here is 180 degrees. So arc RT is 180 degrees. And I need to add the 58 to it. So 180 plus 58 is 238 degrees, okay? All right, questions on that? Let's skip to number 3. All right, again, let's see what we can kind of, can I do anything? Oh, hey, look at this. Let's look at our picture really carefully. We know that SW, arc SW is 72. What else do we know with that 72? Ooh, interesting. Yeah, how do you know UV? Ah, very good. So we have angle SXW here. That has to also be 72 degrees. That's a central angle. And we do have vertical angles, so the other side is also, whoops-a-daisy, 72. All right, which means arc UV is also 72 degrees, so very good. What about, let's see, we have the 87. What else is 87? No. What else is 87? ARCTU. Its corresponding or intercepted arc is also 87 degrees. Okay. All right, let's see what we want to answer here. We want the measure of angle UXV UXV. Hey, what's the measure of angle UXV? You're right here. 72 degrees. I just figured that out. And ST, a measure of arc ST. How are we going to figure out this arc right here, arc ST? But what about this piece? You don't know that piece. Ah, very good. This is important to see that we do have a diameter right here. And so because it's a diameter, we know that it has 180 degrees. So that top half of the circle there should have a total of 180 degrees. So 180 minus 72 minus 87 is going to equal 21. And that is our little arc ST right there. Okay. What's the measure of arc WV? WV, how are we going to figure out this arc? Yeah, again, this is the lower half of the circle. How many degrees does that lower half have? 180. All right, and so again, 180 minus the 72, and that's going to be 108 degrees. All right, let's see, the measure of arc TW. So arc TW goes from here to here. What'd you get? 93. Good. How'd you get 93? Yeah, 21 plus the 72. That's going to give us that 93. How did I know it was the small arc and not the one all the way around? There's only 2 letters, so it has to be the small arc, yeah. Versus this one, TVW. So TVW is the whole other side. So what can we do to get arc TVW? Okay. You said 180 plus 87? That's right. That would work, yeah. 180 degrees plus 87 would work. Could I also do 360 minus the 93 I just found? Yeah. All right, so 360 minus that 93 we just found would also work, and we should get 267. But what you said, 180 plus 87, absolutely correct. Okay. We also knew that this was 108, so 108 plus 72 plus 87 would also work, okay? There are so many ways to figure out what we want to know. Again, good idea here. Number 4, we have, what's this little box mean? 90 degrees. So then we know we have a 90-degree arc there as well. And look here, we do have 2 diameters as well. So anything that goes right through the center, we know is a diameter. So if CD is 90, what's DE? It'd be 90 out here, yeah. Okay. All right. And then, so they told us this 34. What's GF? 90 minus 34, yeah. Again, we have vertical angles right here, so that is also 90 degrees in total. So 90 minus 34, I don't know what that is. 56, thank you. Let's see. So the measure of arc CD we knew was 90 already. The measure of arc FD, how'd you get 124? 90 plus 34, 124. All right, awesome. The measure of arc DCF, big one, DCF, all the way on the other side. You could do that, yeah. 180 plus 56 would work. 236. You're on fire today. All right. And then the measure of arc GDF. GDF is like nearly all of this. GDF is this whole pink arc. How'd you get 304? 360 minus that 56 that we're missing. Good. And that is 304 degrees. Awesome.
Starting to really like this
Right? There's kind of a lot. Like, so when I was in school, we didn't learn this because they were like, no one cares about circles. But they're, you know, the foundation of civilization, right? Like, what was the first major invention? The wheel, okay? The circle changed our lives. And so it's really important. You know, it's where we get the number pi from. Like, there's so many things. But they took it out back in the late 1900s. And then in Common Core, they put it back in. And I got to say, it's a little convoluted. There's things that are good. Like the central angles is good knowledge. There's a couple of things that are really good. But there's some weird things, too. All right. So finding each measure. Writing equations. Here we go. Let's look at number 7. We want to look carefully here at number 7. Pay attention to the numbers that they've given us. So I have here arc DE is 18x minus 2 degrees. I have arc DH is 15 degrees. And I have this 103 degree as well. What can we do with that? Set them equal. How? Okay, so plus the 15 equals 103. Why? Yeah, so the central angles, their corresponding central angles, happen to be vertical. So yes, we have vertical angles in there, so their corresponding arcs would be congruent as well. Okay, let's see, that is 18x plus 13 equals 103. I'm going to subtract 13, 90, and then divide by 18 and get 18? No, that can't be right. 5, 4, 5, 5. Okay, I bet it. Okay. What can we do on number 8? We don't need to do it. They're equal to each other. Those arcs are congruent because, again, we have vertical angles, so they are equal to each other. And again, I think those markings are pretty good. Let's look at number 9. What do you notice about number 9? They add up to equal 180. How do you know that?
Because there's a thingy going down.
A thingy going down the middle. Yeah, a diameter would be the word I think you're looking for. Yeah, all right. So a diameter here, which means that we have to have 180 degrees on that diameter. And so we can add these together. 5x plus 23 plus 17x minus 41 should equal 180 degrees. Let's finish this one up. I concur. 22 x's help 23 and a negative 41 is negative 18 equals 180. Then I'm going to add the 18, so I get 22x equals 198. And then divide by 22. Hit me. 9. Thank you. X equals 9. Okay. If x equals 9, what is the measure of arc JK? 5 times 9 plus the 23, what do we get? 68 degrees, thank you. So then, if this is 68 degrees, what is the measure of arc MJ? Ooh, true. Yeah, it is the same as this. That's true. I was thinking,
Degrees.
how'd you get 112? The same way? Okay. Do you see the other diameter? 180 minus 68, which was what I was thinking. Yeah? Do you see that? 180 minus 68, I think 112. Is that what you got your way as well? Okay. Yeah. So. And then it wants to measure a big arc, LMK. LMK. Oh, let's see. If this is 112,
248.
yeah, 360 minus 112?
Well, I did 180 plus 63, or 68.
And what'd you get?
224, 248.
248. That's what I got too. Yep. Lots of ways, yeah? It's kind of cool. You're ready?
Yeah.
You're good?
Yeah.
All right. Awesome sauce.